Differentiation Part 2 Harder exercises. In this presentation, we'll specify on the 4 cases that you need to rewrite the equation first before you differentiate. For example, if you are given this equation here, you see that it's very difficult to differentiate it as it is because we know that the general rule for differentiation is in this form, and we need to bring the power in the front and then subtract one from the power. So it has to be something with terms of powers. So first we need to rewrite the equation into its simplest form and then differentiate. And there are 4 cases that we need to do that. The first case is when x is on the denominator. Case 2, when there is a root in the equation. Case 3, when there are brackets. In case 4, when there are fractions. So in all these 4 cases, first we need to rewrite the equation before we differentiate. Let's see each case separately. So given this equation here, we need to think how can we rewrite this equation and bring x on the numerator. So we have in terms of powers. We know from laws of indices that if you have negative power, then this is a fraction. Now we need to come back vice versa of that. So if we have x on the denominator, we can bring this on the numerator by change the sign of its power. For example, if we have 1 over x to the power of 3 and we need to bring the x to the power of 3 on the numerator, we change the sign of its power and gets x to the power of minus 3. And 2 over x, we bring the x on the numerator, so it's 2x to the power of minus 1. So let's rewrite this equation. X to the power of 2, if you bring this on the numerator, it becomes x to the power of minus 2. And now you can easily differentiate by bringing the minus 2 times 3, and it gets minus 6x to the power of minus 3. In example 2, here before we differentiate, we need to rewrite the equation. So bring these x on the numerator and x to the power of 4 on the numerator. So change the sign of the power is 1. So it gets x to the power of minus 1, and here the power is 4, so it gets x to the power of minus 4. Do not worry about the number 2 because this is just a number. We just need to bring x on the numerator. And now we differentiate, we subtract 1, we bring the number minus 1 in the front, we multiply and subtract 1 from the power, and minus 4 times this, you get minus 6, subtract 1 from the power, gets minus 5. So let's see some more examples how to rewrite. This you get y is equal to 2x to the power of minus 1. This one is 2/3 x to the power of minus 1. This one is 3 over 5 x to the power of minus 2. And for this one, we see that this term, this one, and this one, they are in the required form. So we need to rewrite the equation for these two. And this term is x to the power of minus 1, and this is 3 over 5 x to the power of minus 2. Here we see that this term and this one, they are like terms, so we can simplify the equation before we differentiate. Case 2, when there is a root. We know from laws of indices that if there is a fractional power, then the numerator represents the power and the denominator represents the root. For example, 9 to the power of 1/2. The number 2 here represents the root, so this is square root of 9. And if we want to rewrite this in terms of powers, then this is a power and this one is the denominator of the power, so it's 4 over 3. Let's go back to this equation. If we want to rewrite this first, then y is equal to x to the power of 1/2, and now you can easily differentiate that. Example 2. This is the power is the root is 3, so this is x to the power of 1/3. The square root of x is x to the power of 1/2. We have rewrite the equation, and now we are in position to differentiate. So 1/3 in the front, subtract 1 from the power, gets minus 2/3. 1/2 in the front, you subtract 1 from 1/2, you get minus 1/2. So some more examples. Square root of x is x to the power of 1/2. 2 times cube root of x, then is 2x to the power of 1/3. Third root x to the power of 4, then this is x to the power of 4 over 3. This is the root, so the denominator, and this is the power. Now this one is the square root of x is on the denominator. So first we need to rewrite this in terms of powers. so that's case 2, x to the power of 1/2. And now your x is on the denominator, so we bring this on the numerator, case 1, by change the sign. The last one, we write each term 5x to the power of 1/2. This is 3 over x to the power of 1/3 and plus x to the power of 3 over 4. We see that this term now we need to bring the x on the numerator, so it's 3x to the power of minus 1/3. Case 3, when there is a multiplication of brackets, since we need to get each component separately, we need to expand. So we expand each term, and now we can differentiate it. Example 2, we have this equation. First you need to expand, you get into this form, and now you can easily differentiate this by differentiate each term. Case 4, when there's a fraction, this means that you need to divide each term by 2. So this 2 here divides each number by 2. So we'll first rewrite the equation like this, and now simplify, and you can easily differentiate. So the answer is 3 over 2. Example 2, we need to divide each component by the number 3. We simplify 3 over 3, it's 1. And now we can easily differentiate this. X squared becomes 2x. 1/2 times 5 over 3 is 5 over 6, x to the power of minus 1/2. And minus 1 times minus is plus 4 over 3x to the power of minus 2. So let's see the first equation we start with. You don't need to worry about this exercise, it's just for practice. So we need to apply all 4 cases here. We need to rewrite the equation first before we differentiate. So we take the first component, it gets x to the power of 1/2. The second component, because x is on the denominator, you bring it on the numerator by changing the sign. And the last one, we see that we first need to expand. Now here we have like terms, so we collect them together. And now this is case 4, when you have fractions, so you need to divide each term by 2x. We simplify the x together, but here we see that there is 1x on the denominator, and we need to bring this on the numerator before we differentiate, so it gets x to the power of minus 1. And now we differentiate, because each component is in terms of powers. The first one, you get 1/2 times 5 is 5 over 2x to the power of minus 1/2, minus 6x to the power of minus 3, plus 1/2, 3 over 2 is constant, so you get 0, and the last one is minus x to the power of minus 2.